Good morning, class 10. Welcome all of you in this mathematics period. Today we have chapter 10, circle. Circle, we have two theorems in this chapter. Before theorem, I would like to explain a few geometrical terms relating to circle. Here I don't like to repeat those terms which you have already learned. For example, center, chord, radius, diameter, semicircle, circumference, etc. All these things you must have learned. Today I will explain two terms, tangent and secant. What is tangent and what is secant? Circle you know very well, and center, the fixed point from which, if all the points are at equal distance, that forms the circle. Tangent is a line which intersects the circle at only one point. In this figure, AB is a line which is touching the circle at one point. So that line is called tangent. And the point where this line intersects or touches the circle, that point is called point of contact. So this is about tangent. Tangent, very simple, a line which intersect the circle at only one point. Second, here in figure number 2, AB is a line. This AB intersecting the circle at 2 points. So this line is called secant. This is the difference between tangent and secant. And here in figure number 3, AB, a line segment. This is line segment which intersect the circle at 2 points. Or in other words, you can say, if we take any 2 points on the circle and if you join, so this line segment is called chord. So this is about tangent, secant and chord, you know very well. And radius, the distance between the center and any point on the circle, that is called radius. Or in other words, you can explain a line segment which joins the center and any point on the circle, that is called radius. Diameter, you know, diameter, the line segment which passes through the center and touches any 2 points on the circle. So that is called diameter. So tangent and secant, these are two important in this chapter, circle. Now you see two theorems as I have told you, but today you will learn theorem number 1. Theorem number 1 is, in a circle, radius is perpendicular. Radius is perpendicular. Suppose this is the circle, this is center, and this is a chord. This is point of contact, suppose, and this is AB, a line segment. Now this is the radius, suppose. So this radius, AB tangent, is the point of contact where this tangent intersecting the circle. So you have to prove, given AB given is AB is a tangent to a circle whose center is O. OP is the radius. You have to prove OP perpendicular on AB. Yani radius is perpendicular to the tangent at point of contact. Point of contact. So given a circle whose center is O, AB AB is a tangent, P is the point of contact where this tangent touching the circle, and from this point if you join the center, this will be radius. Now you see how can you prove some logic in this theorem. So we take 2 points on the tangent AB, suppose C and here D, and you join with the center. You join these 2 points with the center. So now you see OD or OP, which is greater? This is the greater. OD is greater than OP. Bole kyun sir? Because this portion, these two, or in other words you can say B and C are in the exterior of the circle. So any point on the exterior, and if you join with the center, naturally this will be greater than the radius OP, because P is on the plane. On the circle, and therefore OP will be less than OD, or OD will be greater than. Similarly, OC will be also greater than OP. So my dear, by taking more points on the tangent, and if you join with the center, it is very, very simple that all these line segments joining the center will be greater than OP. Or you can say OP is the smallest of all these line segments. This means, or now you can see here, suppose AB is a line segment, P is a point, suppose, here CD. So if you draw many line segments on the AB, so this CD will be the smallest, and any line smallest on a line segment, that is perpendicular to the line segment. Therefore, we can say OP is the smallest, and the smallest line segment on a line or line segment from a fixed point, that will be the perpendicular. That's all. This is the proof of this theorem number 1. What is theorem? In a circle, radius is perpendicular to the tangent at point of contact. At point of contact. Because if you join, this is not radius, this is not radius, so radius will be only OP. Because definition of radius is the line segment joining the center at any point on the circle, that is called radius. So this is theorem number 1. And theorem number 2 you will learn tomorrow. But now I would like to repeat whatever I have explained today. First I explain what is tangent. Tangent Tangent is a line segment, or line you can say, which touches the circle at only one point. That is called tangent. And second, those lines which intersect the circle at 2 points. So that will be second. And chord you know very well. The chord, any line segment joining the 2 points taken on the circle, it may pass through the center or may not pass. And diameter is the only chord which passes through the center. So now you see what is the theorem. A circle whose center is O, OP is the radius, AB is the tangent, point of contact P. Prove OP is perpendicular on AP. We take simply 2 points on the tangent C and D and you join with the center. What do you observe? We observe OC is greater than OP because C and D both are in the exterior of the circle. So it is very natural, this is the extra length of this radius. Up to here, this will be radius. But this is the extra part, so naturally OC will be greater or OD will be greater. By taking more points on AB, we can show OP is the smallest. For any line segment, the smallest line on any other line, that is perpendicular. This is the theorem. So that's all for today, theorem number 1. So tomorrow I will explain theorem number 2. So today is enough. And that's all. You will try to learn this theorem. So thank you and have a nice day.